Okay, till now we discussed about the basic component in Hadoop, HDFS and MapReduce. So why we are using HDFS, why we need the MapReduce, and we discussed about the some HDFS commands and MapReduce. So then we have the if you want to analyze the data in Hadoop ecosystem, we have the tools called Hive and Pig. First, we'll go through Hive. So why we are moving to Hive? If you want to process the data, if you want to analyze the any data, we have the one processing engine called MapReduce. Okay, why we are moving to Hive? So most of the till now, if you observe, if you want to write, if you want to analyze the data, we need to write the MapReduce program. MapReduce program, we need to write the Java. So apart from Java, we can write in other language, but basically everything is developed in Java. So mostly we will write in Java. So if you want to write the small programs or if you want to do small editions also, we need to write the lot of code for the for simple things also we need to write the lot of code. We need to write the mapper class, reducer class, and we need to make the jar. And if you for small changes also, we need to again we need to change in the classes and we need to make the jar file. So it will be little bit complex for the implementing the for the developers, and also whoever working on the this data warehousing tools are it will be they don't have the Java knowledge. Whoever don't have the Java knowledge, for them it will be difficult to learning the Java and again writing the MapReduce program. That is the one more reason. One more reason. So that's why simply most of the IT people are having idea about knowledge about the SQL kind of thing. So if you want to write the SQL kind of queries on the Hadoop, if you want to access the HDFS data by using SQL kind of uh, SQL queries, so it will be very good. So that's why only Hive came into picture. This is all why we are going to instead of MapReduce, Hive. So not alternative for the MapReduce. So MapReduce, Hive is not alternative for the MapReduce. Hive is on top of MapReduce. So Hive is a Hive is a SQL, provide the SQL kind of SQL like interface for accessing the Hadoop, but internally Hive will use the this MapReduce. So if you write the SQL queries, they don't have any own processing engine Hive. So Hive will internally depend on the MapReduce only. But for easy for developers point of easy, so we will instead of writing MapReduce, we will write the SQL queries. Internally, it will convert as a MapReduce program. So what is Hive? Hive is not a database or not database. It is a data warehousing kind of tool. We can perform like ETL kind of operations also. We can extract, we can load the data. We can perform the transformations also. We can perform like group by, order by, count, sum, average, minimum, maximum. We can perform that kind of transformations also. So these kind of things will perform in the Hive. So Hive is a data warehousing tool on top of Hadoop. Okay, Hive is a data warehousing tool on top of Hadoop. So it will provide the SQL-like of interface, provides SQL-like language to analyze the data stored on the HDFS. So whatever we are storing on, under Hive tables, uh, Hive tool won't store, won't have any storage. So basically, whatever the data we are storing, it will be stored into HDFS. So, but uh, actually we'll create the tables and columns, and we will create partitions, and we need to for maintaining this one, we need some storage kind of thing. So that's why in Hive we have the Hive metastore. So in Hive metastore we will store the all the tables information, partition information, uh, uh, which if you store any data, so Hive table where it is stored, in which path HDFS it is stored. That mapping also metastore will have the that mapping also, which table information where it is, which HDFS paths it is stored. All these meta information it will be stored into metastore. So what is the metastore? So metastore is nothing is like a RDMS database. We can maintain any database, maybe Oracle or MySQL. We can maintain, we can keep it any database. By default, Hive, if you didn't configure any database, by default, Hive will have the metastore. So those details I will tell in next slides briefly. So that is about the MySQL, sorry, metastore. Hive tool, whoever having knowledge about the SQL, they can use the Hive. But I think mostly whatever the SQL queries is there, it will support. But some features I think it will Hive won't support. I think some subqueries are not supported, and some things won't be there in the Hive. So we will discuss later what are the things will be there. So actually Hive internally it will be run as a MapReduce job. That is the this point, and no extra work is required. So we don't need to bother about the how it will be converted into MapReduce programs, how many MapReduce programs it will be converted. Only thing is we will write the SQL queries and we will submit to Hive tool. So Hive tool will take care about the converting and giving the result back to client for use. So in Hive we have the some basic components. One is the metastore. So what is the metastore means? It is the database consisting of the table definitions and other metadata. So it will having only information about the tables or columns or partitions, and and mapping information to the HDFS. So that information only it will have the metastore. By default stored on the local machine and Derby database. So if you didn't configure on the any database like Oracle or MySQL, by default it will be stored into Derby. So it will, if you start typing the Hive queries, so automatically it will create some files in local, and it will maintain this table information. So we will see that one. So here Derby, what is the main disadvantage in Derby means? So at a time one user only can access the Derby metastore. So suppose if 10 people are there means they won't use the 10 people at a time. 10 people are not able to write the Hive query. So Derby at a time only one user can use. So mainly this Derby can use for the practice purpose. So in our laptop we can, by default, if you want to practice Hive queries, by default Derby will be there. So we can practice. So mostly in our personal laptop only one user will be there. So in that purpose only the Derby database will use. But in development point of view or production point of view, we won't use the Derby. Mostly we'll use MySQL or Oracle or any Postgres database. We'll use a metastore. Query engine. So Hive query language which gives SQL-like interface. Internally Hive queries are run as a MapReduce job. So this query engine only will convert the Hive queries into MapReduce job. I will show one diagram for this one, all the components. Okay. instead of this component, we have the one more component. We will see all the components. What are the components are there? So basically in Hive, what are the components will be there? We will have the CLI, command line interface. We can write the queries from command line interface, like terminal. We can write the queries, and we have the web interface also will be there, and we can also write the Hive. We can also execute the Hive queries from the any programming language like Java, PHP, or any programming language we can write. So for that we need the either JDBC or ODBC connections. So for that we need the one component called Hive server or the thrift server. So what is the thrift service or thrift server means? So it will provide the communication between the it will provide the cross language support. So by if you enable this thrift service, we can able to write the queries from the JDBC. We can write the programs in the Java or the PHP or any other language, Python or any other language. We can execute the JDBC this SQL queries we can perform. So for that we need to enable the this thrift service. Once if we started the Hive server, automatically in Hive server this feature will be there. But if you want to write the Hive queries from the JDBC using in Java using JDBC, so we need to start the Hive server, and also if the database is in any other remote place, we need to start the metastore also. We need to start. So this is about the Hive server and thrift server. So next coming to metastore. So what is metastore means? We discussed about that one. So it will have the meta information about the tables of this one. So if we are having the this metastore database in remote means we need to start the one service called metastore service, and we need to also start the Hive service. So Hive server. So these things we need to in production environments or development environment, we need to start these two, metastore and the Hive server. We will see later while in our practication we will go through configuring the MySQL also. You'll see first we'll go through Derby database, then we'll go for the other we'll configure MySQL and how we need to start the metastore service and how we can start the Hive server. We'll see that one. So these are the main basic components in the Hive. So this query engine or query driver, this driver, basically this one only will compile, will optimize and will execute. So internally it will convert as a MapReduce job, and it will interact with the Hadoop. So this is the main components in the Hive. So generally how the Hive execution flow is there. So Hive client will submit the SQL will submit the SQL query to the Hive tool. So then what it will do means it will first go to the meta server, and meta server may be any of the relational database or DMS. So it will fetch the meta information and it will convert as a Hive query engine or driver. It will convert as a MapReduce program, and it will interact with the HDFS, and whatever the data we needed, it will fetch the data and it will process the MapReduce, and it will give the whatever the result is there, it will submit to the Hive client. So this is the how the execution flow will involve. This is the diagram. So this is rough skeleton, rough flow of the how the client will submit the SQL query. So how Hive will uh, convert as a MapReduce job, and this one will be interact with the HDFS data, and then this Hive tool will give the result as a this like table structure. It will give whatever the fields we needed. So those fields it will give as a this one. Okay, this is the Hive flow. So we'll go through Hive, how we can install the Hive. Uh, Now, we'll go through how to install the Hive. So in our VMware, we are using the Hive 0.10 version, but latest one is 13 version. So for practicing, we already set up the this 10 version. It will be standard version. So if you want, we can install the latest versions also, but everything we already bundled as a full all the tools. So that's why only we downloaded the 10 version. So in our VM, we will have the 10 version, Hive 10 version. So if you want to install the Hive, first we need to download the Hive from the official website of the Hive. So if you go through Google and if you type Hive download, we'll get the some official sites. So in that, if you go inside, so we will have the latest version called 13 and 14. I think they didn't announce officially. So 13 is the latest version. So if you go inside, so we'll having the gz file, like how the Hadoop file is there, like we'll have the Hive. So this Hive we'll get the gz file, we need to extract, then we will get the different subfolders like bin, conf, lib, how it is there in HDFS, sorry, in Hadoop. So same way we'll have the different subfolder. So once if you downloaded any version, so we need to configure the Hive home, config directory, Hive path. Like this, we need to set the all this path. So in our VM, we already downloaded the Hive. No need to download. If you want to practice, simply we need to go for the that wherever we install the Hive. So we need to go to the that path. So and we need to basically we need to set this path. These paths also already we configured in the bash.rc file. So bash rc file we already configured. So no need to configure. If you want to install manually in new machine, so then we need to download any Hive version and we need to configure all these paths. And we will have the different folders like bin, uh, con folder and lib folder, and log folder also will be there. So in con folder we'll have the ivesite.xml file. So in this here we need to configure the which for which name node we need to connect it, and which job tracker we need to connect it. We need to specify those details here, and we need to specify the Hive metastore warehouse dir. Hive metastore warehouse dir. What is this property means? I till now I'm telling Hive won't store any data, so it needs to be stored into HDFS. So from to where we need to provide the HDFS path where the all the Hive tables data it needs to be stored. We need to provide the path. So that path is the Hive metastore warehouse.dir. This is the HDFS path. So once we start the Hive and we are writing it, creating the tables, so it will whatever the data we are going to store, it will create the subfolders for the each table. Then under this one, the data it will be there in the HDFS. So this is the default path for the Hive data. So if you want, we can change this path, but for standard purpose, they will use this one, Hive user Hive warehouse. If you want, we can change this path. So creating directories, I think This is the path we need to create in the Hadoop. I think mostly we don't need to create the path. So once if you started the Hive and if you started creating tables, automatically this path will be created. If you want, we can create, and instead of that one, automatically Hive tool will take care about that creating the database. So if you want to write the any queries, if you want to start the Hive cell, what we need to type the Hive, then we'll go to the Hive prompt. So there we can write the Hive queries. We will see that one. So in Hive data models means we have the different kind of data models like database, table, partition, and buckets and buckets. So generally, like normal databases, we can create the different databases for the naming convention. So we'll create the namespace, separate the tables from the other units from the naming confliction. So that's why only we'll create databases. Table is normal table we can create, and partition means, so I will give more details. Partition is nothing but a, instead of storing all the full data on the table, we will create the data as a different partitions. So while practicing the Hive, you'll get more details about the partition, but main use of this partition means, so we can instead of suppose if you want to perform the table, instead of accessing the full table data, so we will divide the data into different partitions. So nothing but we will create some subfolders. So we instead of interacting with the full table, we will interact with the only particular partition. So because of that one, we can improve the lot of performance. So we will see that one. So how we can, what is the partition, and while writing the queries, I will explain clearly. And buckets also like a sub-partitions of the subfolders of the partition. So this thing also, buckets and partitions also, next classes I will give you clear idea. These four are the main mainly we'll use the in Hive database tables. I think till data in RDMS also, I think maybe you will have idea about the what is database, what is table, and maybe you will have little bit idea about the partitions also in RDMS. But maybe this concept is a new concept in the Hive buckets. These two are for improving the performance. Hive performance only we will use the partition and buckets. Okay, coming to data types. These are the data types Hive will support. If you want to store any string, directly we'll have the string, and int, small int, like the float, boolean, double, and like this timestamp also we'll have. So these are the some standard types. So for every version, they are adding new types also. And I think in Hive we have the some new data types. I think that data types won't be there in the RDMS. So those are the array, map, and struct. So these are the uh, Java Java data types. So Hive internally they implement in Java. So they introduce these data types also in Hive. Array, map, and struct they introduce in Hive also. So instead of storing the string and integer value, we can store the map key value pairs also we can store. We can store the list of values like array also we can store. We can store the some records kind of things, column name and data types we can store as struct. So these are the some new data types in the complex data types in the Hive. So these are the basic queries. How we can, if you want to see the what are the databases, we need to create the show database. We need to write the query show database. And if you want to see the what are the tables are existed, we need to type the query show tables. These are the show database and show tables. For if you want to see the tables or existing tables and existing database. These are the queries. And if you want to here how we can create the, how we can insert the data, that is the main it will be these are the different from the RDMS. Fully these are the different from the RDMS. So if you want to analyze any data while creating the table, we will specify the what are the fields that exist, and apart from the fields we need to specify the some keywords like delimited fields terminated by. Here they are specifying the space, lines terminated by \n, and stored as a text file. So these are the Hive keywords. These keywords. Apart from this, syntax is same like a RDMS general SQL query. These are the new keywords: row format delimited, fields terminated by space, and lines terminated by /n, and stored as a text file. So if you want to suppose if you have the data as a comma separated or space separated, so here we need to specify the this thing. So row format delimited, fields terminated by. So what is the delimiter for our input data? We need to specify. So for separating the data, we need to specify this one, and lines terminated we need to specify the \n. I think mostly we no need to provide this one. So if we apart from \n, if you having the any other things, so then we need to provide this one. So basically by default it will be \n only. If you didn't provide also, it will be okay. You can execute. So, and if you want, we need to here stored as a text file means generally it will store as a text. Instead of text file, we'll have the different options in the Hive, like sequence file or any other formats will be there. So some other formats will be there. By default, we will use the text file. This is the basic syntax of the create table. We will see next. While practicing, I will tell more details on this one. If you want to, once if you created, if you want to see the details about the table, we need to use the describe table name. So here the main concept in the Hive. So generally in RDMS tables, if you want to insert the data, we will use the some insert into table, and we will write one by one record will insert. But in Hive we can't write the single insert and single update operations, and also we can't delete the single row deletions also, it won't support. So Hive means it is a kind of bulk processing tool. Bulk processing means we will have the data in one folder. We'll have the some bulk amount of data, maybe 1 GB, 10 GB data, 10 GB, some amount of data will be there. So we will load that amount of data into table or a Hive table or Hive partition. So whatever the operations for the analysis needed, so we will perform that one, and we will store into some other Hive tables, or we will store into some RDMS tables. Whatever the analyzed data is there, we will store into some other Hive tables, or some Hive results table, or some, if you want, we can move to the, by using scoop, we can move to the RDMS tables, we can move it. So this is what we will do in the Hive. So for that one, we need to load the data into, if you want to load the data into Hive, this is the command: load data in path sample underscore data into table. So whatever the wherever the input data is there, we will provide that path. So here one question is, this sample underscore data is the local path or the hrefs path. So we can provide the both path. We can provide either hrefs path, or we can provide the normal Linux path also we can provide. So if you want to provide the normal Linux machine or the normal OS local path, we need to specify the load data local in path, and we need to give the local path. Instead of that one, if you provide the hrefs path instead of local, we need to write this. This is the query to load the hrefs data. So that local option also we will see next slides or next examples we will see. So once if you create the table and once you loaded the data, so HDFS how it will be stored means, so this is the default path we discussed in the previous slides. So user Hive warehouse, under that it will create one folder with the table name. Under this table we will have the sample underscore data. So this is about the this how we can create the table and how we can load the loading data into from the local file system. This is the option. So previous example we don't have this keyword local. So here if you want to load the data from the local file system, we have the load data local import. So once if you store the data under the Hive table, we can write the basic SQL query, select star from sample and select star from sample where, and we can provide the group by order by limit. All these queries we can write. Once if you write the queries, it will be executed at the MapReduce jobs. How you can create the tables, how you can load the data from local or HDFS, how you can write the SQL queries. So we will we'll see in our VM, we'll see how we can do it, how we can start, how we can write the Hive queries, we'll see. Here one point is before running the Hive queries, we must we need to check the whether all the Hadoop service, Hadoop HDFS and MapReduce are running. We need to check by using JPS commands, or we need to go through 50070 or the job tracker UI or name node UI. By using that one, we need to check whether it is running or not. So before starting a Hive queries, we need to check the whether Hadoop is running or not. We need to check. So in our VM, we already downloaded and installed in the user local Hive. So this is the path. So here we'll have the con file, bin file, lib folder also will have. So we'll go through con, cd con. So here we'll have the Hive site.xml. So if you go through here, what are the things we discussed? So these things will be the Hive metastore warehouse and the default name and the job tracker. So here localhost is there. We need to change to master. So we are running everything through master. So here whatever the name node, whatever the host name, name node host name, we need to provide that one. So here instead of local, I'm changing to master. So same like here also for job tracker also we need to change the master host name. So that's all. Apart from all these things are same. So we need to change the instead of localhost. If you want to practice in the this two node cluster master and slave one, we need to change as a instead of localhost, we need to change as a master. Then directly we can go through the go to this Hive folder and you can start the this one Hive. So if you observe here, once if you start at the Hive top, it will create the this one. It will create one folder called Derby with Derby name. So we will see that one. Basically, in our local, wherever you are starting, we are running this Hive command. So then that folder it will create the Derby with Derby folders. It will create. So if you want to practice, first we need to type the Hive and this one. So then we can write the whatever the commands we discussed, show tables, show databases, we can execute. So before going to that one, I will see, once if you start creating the any table, automatically here it will create one thing called there be folders will come. I will show that one. So currently we don't have any databases. So if you check it, simply we'll write any Hive query, automatically it will create these folders metastore underscore db. Under this folder, temporarily for our single, if you want, now we are practicing as a single user. So whatever the information, meta information, it will be stored under this folder. So if you start executing Hive from the some other directory, suppose it is from the some other directory here. Here if you do type the Hive, so here also it will create the metastore underscore this folder, it will create metastore underscore db. So for this db, try to run the all the this Hive queries from the single folder only. Try to execute from the one folder only. Any folder you can try to run it. So this is only problem in the Derby. So if you configure as MySQL, we didn't get problems like this. So if you configure as a MySQL, so no need to bother about the from which folder we need to run it. So we can run from the any folder. We can any folder we can type the Hive and we can go to Hive prompt and we can run the Hive queries. We can run from any folder. So for this Derby only, we need to for each wherever suppose if you are typing the Hive prompt, it will be this meta information, it will be different. So this point I will tell more details on this point later. So if you start writing some creating the tables, then we'll give then I will give more details on this what is metastore underscore db, what is the limitation of this one, I will tell you. So this is how, if you want to start with the Hive queries, we need to start the Hive. We need to type the Hive simply, then we can write the all the we can create the databases, we can create the tables. So this is the, if you want to practice Hive, you can go through the Anson book. Then if you want to go inside, you need to type the Hive. Then if you want to list the database, we need to use the show databases. Then if you want to create the database, we can create the database like create database mydb. So this is how we can create the database. Create database. Once you created, you can see the, if you type the show databases, you'll get the, what are the existing database. Default is this is the default database. So if you want to create, we can create our own database. So once if you create the database, so it will be like this. We'll get the folder like this. This is the default path. User Hive warehouse is the default path. Under this path, we will get the this database. Will whatever the database we are creating, we will get the one directory with the name, database name mydb.db. So under this, if we create any tables, we'll get the folder like this, docs like this. Whatever the table we created, that name will one folder will create with that name. So if you want to switch to database, we need to use mydb. Then if you want to see the tables, you need to use the show tables. If you want to get the more details about the database, we need to use the describe database, more extend and mydb database name we need to give. Here it will display what is the database name, where it is point to HTTPS location. This is the meta information what we will store into metastore. So metastore will store this information. So like So database where it is pointed to HDFS, or particular table where it is pointed to HDFS location, or any partitions or what are the table name and the column information. All this information we will store into metastore. We will store. So this is how we can create the database and how we can see the tables and how we can see the details about the database. So then, if you want to create the table, simply we can, this is the sample query, create table, table name and the field name and the data type. We can, what are the data types we saw previous slides, we can use those things, string in those data types we can see, you can use here. This is the column name, what is the column name. So here we are not specifying the any delimiter. So why means we are taking each line as a single column. So that's why we are not using any delimiter. Next example we'll see how we can specify the delimiter. Now we can load the different fields into table. We'll see. So once we created, we will get the folder in the HDFS like this. We'll get the folder, docs folder we'll get. So if you want to see the tables, show tables, we'll get what are the tables are exist. So these are the commands. So then once you create the tables, we need to load the data. Command for the loading the data. So what we'll do means, we will, this is the command, load data is command. We are pointing, so loading into HDFS directly, I'm pointing the local path, and this is the path. I have this folder Shakespeare. So this the data I'm loading into, I'm trying to load into docs. This docs table I'm trying to load. So whatever the data is there, it will. So I think we have the 5 files. So it will give the information like this: copying data, copying file. Once completed, for every command, it will give the like this time, how much time it is taken. For every Hive command, it will give like this time taken and how much time it is taken. These two will come. Apart from output, it will come OK and time taken. These two will come once if you executed any query. So this is how we can load the data into under Hive tables. How we can load the local path data directly to the this one. How we can load into this particular Hive table. So if you observe here, so under this folder, that local path, local data, we can copy to this one. So like this, we will get the data under this one. So once we got the loaded the data underscore Hive table, directly we can perform the this one. We can directly write the queries, all the SQL kind of queries we can write it. So if you want to load the data from the HDFS, we can write the load data in path Shakespeare into table. Here if you load from the HDFS, whatever the data we are pointing, simply what suppose difference between this command and this command is, it will load the, suppose if you have the 1 GB file, it needs to be loaded into first HDFS, so it will take a lot of time. If the already data is exist in the HDFS, if you load the you're trying to load the HDFS data into Hive table, simply what will do means it will perform the move operations. It will cut the data from the whatever the current in the current location of the HDFS, and it will copy to the whatever the this user Hive warehouse is there. It will copy to the that place. It will copy the whatever the HDFS data. This thing we will see later while practicing. We will get this point. main thing for the local, and this one means local means directly it will like a copy operations. It will copy and paste. If you copy the HDFS, if you are trying to load the HDFS data, so then it will be cut copy in the HDFS. If you trying to load the HDFS data, it will the cut copy operation HDFS. If you trying to load the local data, it is the copy paste operation for the local data. So we will see that one later. While we are practicing, we'll get more clarity and more details on this one. Loading the local data, HDFS data. From then we can write the this thing. We can write the select star from docs operation. We'll give some limit, otherwise it will display a lot of data. Now I will give limit 5. I think first all the data is the space. So like this we can print the data. And if you want to see the tables information, we'll see describe docs. So it will give the what are the fields are there. You can see that fields information. And also if you give the show table extend like docs, so this one will give the more details for the table. Extend will give the more details. So it will give the where it is located, this table where it is located. This is the path. What is the input and output format, text input format, output format. What are the fields? What is the maximum size, file size, minimum file size, total file size? So it will give all these information, extra information also. It will give instead of column names, table name and column name. It will give the all the this one. It will give the information about the other details also. Just if you give the describe, it will give only what are the columns and data types. Here it will give the other information apart from the columns. It will give the other information also. So this is how we can create the table, how we can create the table, how we can create database table, how we can see the table information, how we can create the sample table, and how we can load the data, how we can create this thing, how we can create the SQL queries. We'll practice one more example. So I'm going to create one sample table like employee table. So this is the sample data. This is the sample data I'm having. So this having the 4 fields. First field is the ID. Second field is the employee name. Third field is the what are the technology, and fourth field is the what are the company name. So like this, I'm going to this is my input data. So how we can create table for this data, how we can load this data, how we can write the queries. So if you want to get the name, how we can get internally, how it will be converted as a map to this program, we'll see that one. So here for that I'm first I will create one file for this one, employee.txt. First we'll create the this one in the local directory. I will move to the home, training materials, data. Here I'm going to create one folder called employee.txt. So I'm copying these 4 lines. So now we have the data like this. employee.txt. So data, we have the 4 records and we have the 4 columns. So each column is separated by the comma. So this data, how we can create the table for this one, how we can load into Hive, we will see that. So I will come out from the Hive. If you want to come out from the Hive prompt, we need to type the exist, and simply I am typing it. So show tables. Currently, I think we don't have any tables under the default DB. So previously we created the table under the this one. We created under MyDB. That's why only by default default database will be there. Here we don't have any tables. Here I will create the tables. Now how we will get the this also instead of database. By default database, how the folders will come, that also we'll see. So for that one, first I'm going to create the table. So this is the table structure, create table, employee. These are my 4 fields: ID, name, technology, company. Up to this one, like previous example, up to this one same. After that we are using this keyword. Row format, delimited fields terminated by comma. So our fields, our input data is separated by the fields are separated by the comma. So that's why I'm giving the comma separate. So we'll create table, then we'll see. So this is the syntax how we can create the table with the in the Hive. So create table. Now we'll give show tables. So this is the table we created employee. So if you check here will by default, if you create a table underscore by default database, it won't create any .db folder. Directly under this path, it will create the table name. Whatever the table we created, it will create the folder with that name. So now we will store or load that data. So simply load data local in path, wherever the data is there, that path, that file name, and we need to specify it into table. Table name we need to specify. So data is loaded. So if you want to one question, good question from the Jitendra. Yes, his question is extra comma in the latest last line of the text file. Will it create any problem? No. I don't create any problem. I will tell once this example is completed. I will come to your point, Jitendra. I will explain that also. So this is how we can create and load. Then if you want to see the this table columns details, you can go through describe employee. It will give the what are the columns are there. Then if you want to get the all the fields data, then simply we will write the select star from employee. So for this select star, it won't convert as a map reduce. Simply whatever the data is there, it will be split by the command, it will display. Instead of that one, if you write the if you want to fetch any name on technology, then if you write command like this, if you fetch the details for the any field, or if you want to count the number of records, or if you want to perform any group by operation, then it will convert as a MapReduce job. So once if you run this command, it will convert as a MapReduce job. So this will be, so if you write, if you are trying to fetch some data, name and technology from employee, then it will become automatically, it will convert as a MapReduce job. So if you go to, then if you go to the job tracker, you can see this as a MapReduce job, you can see. So generally, if we submit, if we if we write the query select name from employee like that, so it will be converted as a MapReduce job and it will submit to the job tracker. So here, if you check it, how the MapReduce jobs we can see here. So like that, if we submit the Hive query, it will convert as a MapReduce job, and we can see here in job tracker. So tomorrow we will see how it will be convert as a MapReduce program, how we can see in the job tracker. Tomorrow we'll go through that one, and we'll practice some other examples. We'll go through that one, and we'll discuss some other Hive concepts, partition and everything. We'll see it tomorrow. Okay, thank you all.